Hello and welcome to Mathematics Illuminated, where I shed light on any and all math topics from simple to advanced in a way that's easy to understand and interesting to learn. Please subscribe to my channel as I continue to post more videos, and comment below on videos you would like to see in the future. Today I will be going over proving the quadratic formula, with a thorough explanation on the mindset behind the proof. First, I'll go over what a quadratic equation is. Notice that there is a difference between a quadratic equation and the quadratic formula, which I'm about to get into. A quadratic equation is defined as an equation ax squared plus bx plus c, where a, b, and c are constant numbers. An example of a quadratic equation would be 2x squared plus 3x minus 2. Here, a would be 2, b would be 3, and c would be negative 2. The quadratic formula, however, is derived from setting a quadratic equation equal to 0 and then solving for x. In other words, you are solving for certain numbers x for which ax squared plus bx plus c is equal to 0, given values for a, b, and c. This is the famous quadratic formula, which many of you are probably familiar with. There are even songs for this, which can help people remember it. The quadratic formula is, given that ax squared plus bx plus c is equal to 0, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. But this is usually given to students as a good thing to memorize. The proof for this is not as well known. So, how do we prove this? Well, the method for proving this may seem a bit complicated to some, but I hope to show its simplicity through a careful evaluation of the problem we're trying to solve and how to solve it. Our problem is solving ax squared plus bx plus c equals 0 for x. This is done by the method of doing the same operation to both sides of the equation. First, we're going to subtract c from both sides, getting you that ax squared plus bx is equal to negative c. Then we're going to divide both sides by a, leaving you with x squared plus b over ax is equal to negative c over a. The next step in this proof is the most complicated part, so I will attempt a thorough explanation on this step. What we want to do is rewrite what we have on the left, x squared plus b over ax, as x plus y squared, where we do not currently know what y is. Once this has been done, we can take the square root of both sides. So, let's look at what it means to rewrite it. We're trying to rewrite it as x plus y squared, which can be expanded to equal x squared plus 2xy plus y squared. Going back to what we had before, we find that we are trying to rewrite what we have on the left as x squared plus 2xy plus y squared, where we have not yet defined what y is. Since these two are said to be equal to each other, and the first is equal to negative c over a, we can write that the second is also equal to negative c over a. Next, we can rearrange the x and y terms here, since we are dealing with multiplication. Now that we have done this, we can notice that b over a and 2y are equal to each other, since they are both what is multiplied by x in each of the parts of the equation. So, now we know what our y should be. It should be the number for which 2y is equal to b over a. Dividing both sides of this equation by 2 gives us that our y is equal to b over 2a. Now that we know what our y is, we can also know what our y squared is by rewriting it as b over 2a squared. And this is equal to b squared over 4a squared. Now we can notice that the only difference between this part of the equation and this part of the equation, since these terms are equal, is the y squared term. And since we know that the y squared term can be rewritten as this, all we need to do to this, to make it equal to this, and recall that's the whole point of this step of the proof, is to add y squared, which is b squared over 4a squared, to this. So, our next step in proving the quadratic formula is adding b squared over 4a squared to both sides. And recall that the only reason we are doing this is to rewrite what we have on the left of the equation as x plus y squared. And knowing y is equal to b over 2a, we can substitute it in for y. And there we go. We have now completed the most complicated step of the proof, and this is what we are left with. All we have now is to solve from here. First, let's rewrite this term as one fraction. We'll rearrange the term so that instead of adding negative c over a, we are subtracting c over a. Next, we'll combine this into one fraction by rewriting c over a. Since we are dealing with a fraction, we can multiply both the numerator and denominator by 4a. Next, we simplify. Now that the denominator of both fractions are the same, we can combine them into one fraction. Now that we have rewritten this, we can go back to what we had before, and rewrite this. Our next step is to take the square root of both sides, making sure that we take both a positive and negative square root. If you are unfamiliar with doing this, the reason we take both a positive and negative square root is because, let's say we are taking the square root of 4, both 2 and negative 2 squared is 4, so the square root of 4 is both 2 and negative 2. In our proof, we write the positive and negative as plus or minus, which is the symbol shown here. Now we can split the radical, which is a square root symbol, into both the numerator and denominator. The square root of 4a squared is just 2a, since 2a squared is 4a squared. So now we'll rewrite that as 2a and put the plus or minus symbol in the numerator. If you are wondering why we didn't take both the positive and negative square root of 4a squared, it is because the positive and negative was already taken into account in the first radical that we extended into the denominator. Now I'll minimize everything for our last step. We're going to subtract b over 2a from both sides, thus isolating x. We can notice that both fractions have the same denominator, so we can combine them. Now, instead of subtracting b, we can rewrite it as adding negative b to the front of the formula. And here we go. We have now proved the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Thanks for watching. If you did not understand a part of this proof, please leave a comment. If you enjoyed seeing how this all played out, please like and subscribe. Farewell for now.